Okay, so I hope you have been enjoying the discussion on slopes, and you have now some understanding about what we mean by slope and how what kind of slope you can expect at different points of a mountain, okay, about its hills and its peaks and its valleys. So today, okay, before proceeding, are there any questions? No. Okay, so let's progress. Let's start our discussion. Okay, so this is out, and what is this? Okay, so you remember that we said last time that now you can forget about these curves as representing the heights of mountains as a function of x. Rather, you treat these as arbitrary functions, okay, whatever function it is. We don't have to attach a meaning to it like its height of something. It could be anything. So we call it f of x, and so that's graph of some function. So that's x and some function of x, okay, and that's the origin. Now I showed you last time that if you take a straight line and you ask what's the slope, okay, then you find that the slope is independent of the position at which you are asking what the slope is, okay. It turned out to be a constant. The right hand side was m, okay, if you recall. Now let's take arbitrary smooth curve. So I emphasize I'm taking smooth, okay, so that's a constraint I put, and you will later see why that's a useful thing. So imagine that's a function f of x. I have given you for different values of x, and suppose you want to know the derivative, sorry, the slope okay, if I can be little, let's draw it neatly. It will be useful to have a neater diagram. So let's take this and let's say so at this point, meaning at this value of x, I want to know the slope. Okay, don't think like I want to know the slope here. You want to know the slope at this point. That's the value x, okay. So what you will do is, I don't know why it's moving. Now I will say, okay, you remember what the slope is. Slope is if you draw a tangent, you draw a line there, tangent to the curve, then the slope of that line would be the slope of this curve at that point. If you draw a line here, tangent to it, whatever the slope of that line is, let's call it m, that m will be the slope of this function at this x, right? So how do I get that? So let's start with some crude approximation. I don't want to know exactly at this moment. If I am able to make a crude estimate of the slope at that point, I'll be happy. So let's take another point somewhere here, okay, and so let's choose another value of x, any value of x, it does not matter which one, okay. So that's the point x at which you want to know. So this is x-axis. On this x-axis I have chosen a point x where I want to know the slope. So at x, what is the slope? That's my question. I arbitrarily choose a point. I want to call it x plus a, or okay, I should have chosen a little further away. Okay, so I'll do that. I don't know, is there a way to, okay, fine, x plus a. So this is x plus a. What is the distance between these 2 points? That is a, x plus a minus x, that is a, okay. Now I say now I connect these 2 points, this point and that point. This will be visible? Let's try. Is it visible in the camera? Actually, good. So I say the slope of this line is an approximation to the slope at point x. Okay, so let me draw it. We'll go slow, okay, because this is important. So we'll go slow. Here, sorry, I want to do this, take that, it was fine. Right, that's the tangent. The slope of this line is your answer. Okay, we want to arrive at that answer by a systematic procedure. So I start by taking any arbitrary point x plus a away from x, a is positive, take it, take the value of the function on this at x equal to a, so the value here is f of x plus a. The value here is f of x. What's the slope of this pink line? Remember we saw last time, how do you get the slope of a line? Slope of this pink line is y2 minus y1 over x2 minus x1. What is y2 here? F of x plus a. What is y1? F of x. So slope of line 1, I'll call it line 1, of line 1 is y2 minus y1. What is y2? This value of the function at this point. Okay, so f of x plus a minus f of x divided by x2 minus x1. What is x2? X plus a. What is this? X. So it is a. Okay, now you might not be very happy. You say, okay, that's actually very bad. It doesn't look like very close to it, but you have some value. Okay, now if you're not happy with this answer or this approximation, we can improve our approximation.
Which one is line 1?
This is line 1.
Pink one.
So this is, how did I get line 1? Take any point, whichever you like. If you don't like this one, take a point here. Connect it here and then use this. That will be your line 1. Okay. Now let's improve our estimate because you are not happy with what I have given. Let's take another point here. Okay, let's take this one. Is that straight? Yes. And now connect this point on your original point. You want to know the slope here, right? So I'll take this point and connect to that one. Okay, I wish it had started neatly here, but I think you understand. Now the slope of this one is more close to the slope of this one compared to that one. So as you are coming closer to the point x, your estimate of slope is getting better. Okay, let's call this as x plus b. Okay, that point is x plus b. Now let's take another one. Let's take another one. Here, and then connect that. Now I again start from this point on the curve and I connect that one. Okay. The slope of this new third line is even better than the second line. It's even closer to the slope of the line that you have drawn tangent to the curve. So you see, as you are coming closer and closer to point x, your estimate of slope is getting better and better, right? So now we have a procedure, and you can imagine if I were to keep it bringing closer and closer, you are eventually going to get a very small piece of line, but that you can extend to infinity, it's not a problem. A very, very small piece of line, as small as you wish, close to x, and that will have exactly that slope. Is that point clear?
Yes.
Okay, so here I will just, for the sake of completeness, I will write it. So that's line 2, that's line 3, and so on, and so on. So slope of line 3 is f of x plus c minus f of x over c. I think I didn't write c there. I'll just write it down. So that is x plus c. Okay. So what will be the exact slope? Okay, exact slope at that point. Maybe I can. Okay, let me just first tell you what it is. So you say, okay, I take let's call it x plus h. So that point is x plus h, and h we will let arbitrary. So h is a variable now. H can take value a, b, c, whatever. Okay. So slope at this point x, slope at x, okay, is how much? It is like this, f of x plus h minus f of x divided by h, right? Because if I connect this and that, I should take value of function at this point, value of function at that point, take the difference, that gives you the height, okay, and divide by h. That gives the slope of that line, okay. Now I take h to be smaller and smaller and smaller, and take h eventually go to 0. When you take h eventually go to 0, you are going to get the slope at x. So this is fine, this is not fine, this is approximate. This gives you a number which depends on h. But if I take h going to 0, that gives you the slope. Agreed? Okay, I have taken h to be positive here. This is finally the way you are going to get slope at a given point x, and this will work for every function. Okay, and you might be wondering, why did I say in the beginning that I'll put a restriction of looking at smooth functions only? Okay, we'll come to that point a little later, but you should be thinking, oh, why was there a restriction put? Okay, and the answer has to do with the fact that, okay, and a related fact is that I have been going only this way. I could have come that way also. Okay, So we will answer these things. What is the relation between all these statements and qualifications? Okay, so that's the slope. I will now introduce some notation. So this portion is captured? Okay. So given a function f, okay, usually written as f of x, its slope at x is given by whatever I am writing right now. It's not precise, okay? We'll make it precise. But I want to go slow so that you really understand why, when I give you the precise definition, those elements are needed in the definition. So right now, whatever I'm saying is good, provided your function is a smooth function, okay? But we'll make it more precise. So for a smooth function, this is perfect. This is no problem. There is no problem. Its slope at x is given by what? F of x plus h minus f of x. So you want to know the slope at x, that is this x. Take any arbitrary h which is positive, okay? Take this difference, divide by h, and then take the limit h going to 0. I am assuming that you have studied limits, okay? You know how to take limits. That's the definition. Sometimes, or actually most of the times, or a lot of times, people do not write like this. People prefer writing the same thing as f of x, f of x plus h minus f of x divided by h. And instead of putting a semicolon and saying h goes to 0, they will say limit h goes to 0. Okay, it's the same thing. If you don't like this, write it that one. Okay, it says h goes to 0, h tends to 0. This also says h tends to 0. So the limit of this as h tends to 0. That's the same thing here. Okay, that will give you the slope. It's useful to have a notation. Okay, the notation for this entire symbol is this. So slope at position x is denoted by f prime x. Okay, so the slope at the point x is given by this, and it is denoted by f prime x. Remember, this is prime, this is not dash, so I will call it prime. That's f prime of x. Okay, good. Now if you know the definition of this, let me take you back to our expedition. You remember, someone had given you a chart or a graph telling you about the mountain, but didn't give you the shape of the mountain, didn't tell you the height, okay, different values, but it gave you the slope. So you were given a graph which was telling you about the slope of the mountain on which you want to climb. Now imagine when you have finally climbed it up or climbed it down, you know the shape of it, okay, and now you want to reconstruct back that curve, that graph that was given to you. So I will give you the shape of the mountain, exact function of it, and we will try to figure out the shape of that map that was given to you, which was giving you the slope. Is the question clear? So the easiest function that we could have is a line, but line is very simple, slope is constant, so slope is same everywhere. So we'll take the next thing, we'll take the square, x square, okay? So here is an example. Imagine Imagine that's the function that is given to you. So you are actually in a valley in the mountains. Okay, that's the shape. Now we want to know what was the map given to you which had the slope. Okay, so how I take any point x here, okay, and I want to know what's the slope. So what is it? Remember the procedure. Take any other point x plus h, okay, and go towards it from the right. That's what I have told you so far. So we'll go from the right towards the value x. So what's the slope? So f of x is x square, and what do I want to know? Want to know the slope. And how do you denote it? F prime of x this is what you want to know. Okay, and what's the meaning of f prime? F prime, my goodness, f prime of x is given by this procedure: f of x plus h minus f of x divided by h, and then take limit h going to 0. Okay, find this object out as h goes to 0. That's what you want to do. So let's find out what is f of x plus h. F of x plus h in this case is, what is f? F is x square. So it is x plus h whole square. This is x square plus 2hx plus x square. Okay, that's good. Okay. Okay, now let's make this difference. So f of x plus h minus f of x is equal to x square plus 2hx plus h square minus x square, which gives you 2hx plus h square. Okay, so I have the numerator now. Let's divide by h and take the limit h going to 0. So f prime of x, meaning the slope at x, is equal to 2xh divided by plus h square divided by h will give you, so this h will go away, it's 2x plus it will give you h as h goes to, in the limit h goes to 0. What is it in the limit h goes to 0? What happens to this term as h goes to 0? Nothing happens. There is no h. What happens to that term? It goes to 0. So in the limit, this is 2x. So what's the map that was given to you? It was this. The map was this. Okay. They gave this to you. This is the curve that was given you on the map, if this was the value. Now you see, here the height of this curve is increasing linearly. That's a linear relation. That's linear, right? 2x, it's line. So as you go further and further out, the rate at which the height is increasing increases. How it increases? It becomes proportional to x where you are, right? So it's, if you had a straight line here, then in equal intervals the height increases by equal amounts. But here, even that increase in height, the rate of increase in height is also increasing. Okay. So anyway, that's the derivative. So f prime of x is 2x. Okay. So I'll give you 3 functions and you tell me what are the slopes of those functions. So if f of x is a constant, if f of x, if the function is linear, if the function is quadratic. Suppose these functions are given to you. You have to find f prime of x. So what's the slope of a constant function? A constant function is like this. Okay, its slope is 0, it's horizontal. So f prime of x is 0. Okay, we can check. Let's check. F of x is a constant c. What is f at x plus h?
C.
That is c. What is f of x? That's c. What is f prime of x? It is c, which is fx plus h, minus f of x divided by h. That's 0 divided by h. And this is 0, always 0, irrespective of what h is doing. Okay, so f prime of x is 0. Slope of a constant function is 0. How about the slope of a line? Let's check this. F of x plus h will be, if f of x is x, then f of x plus h is x plus h. Correct? What is f prime of x? Is x plus h. F of x plus h
Minus X.
minus f of x, which is just x divided by h, as h goes to 0. As h tends to 0. Okay? What is that? This is x minus x goes away. You have h over h, which is 1. 1 as h goes to 0. But 1 remains 1 because that doesn't change as h goes to 0. So your answer is 1. So for this one, and that you already knew, right? Because f of x is equal to x is a line that makes 45 degrees from the x-axis and the slope is 1. So my procedure, my definition is giving correctly. If it didn't give correctly, then either I made a mistake or my definition is wrong. And this one we did just a few minutes back. So what is that?
2x.
2x. One more? Shall we do one more? Okay. Now since that we are happily taking slope, so let's take slope of one more. It is just that I want to do it for a cube, but I don't remember the formula for a cube. Anyway, let's do it. So let's take f of x is equal to x cube, and I want to know the slope at point x. Okay. So what is f of x plus h?
X plus H whole cube.
Is x plus h whole cube, which is x cube plus 3h x square plus 3h square x plus h cube. Is this correct? Okay, is that correct? Okay, let's check whether this is correct. If you are not sure, let's take h also to be x. Then it becomes 2x cube. That should be 8x cube. Let's see whether that will give you the right answer. So x cube, 3x cube, 3x cube, x cube. So 3 plus 3, 6, 7 plus 1, 8, 8x cube. So that's correct. Okay, so we have a test. I will maybe later tell you something more about how to think of these things. Okay, it will be very useful, but maybe a little later. So here it's fine. Oh, I don't like the way I have written it. I will rewrite it. I will write it as x cube plus 3h square x plus 3h x cube plus, no, sorry, it was good. I'm sorry. I
Corrected.
I like what I have already. This is what I wanted. So that's, I'll tell you what I was thinking. In this, there is no h, meaning h to the 0. H to the 0 is 1. This term is linear in h. That term is quadratic in h. That term is cubic in h. So I want to arrange the terms like this. Okay? I mean, you don't have to, but your thoughts get organized nicely if you are organizing it this way. Okay, so let's take the derivative. F prime of x is f of x plus h minus f of x divided by h, take h going to 0. Okay, what is that? This is x cube plus 3hx square plus 3h square x plus h cube minus x cube as x goes to 0. Is that okay? Remember, this will happen always. The term with h to the 0, meaning without any powers of h, will just get cancelled. Because at s goes to 0, the function is same, right? So f of x plus h is f of x as h goes to 0. So they will cancel always. Okay? Now, we have h, this has h, this is linear in h, so that h goes away and leaves behind something which does not have a power of h. That's important. The term which is linear in h, after division will become a term which does not have h in it, or it becomes h to the 0. Okay? So what does that give? 3x square plus this, when you divide, gives you a term linear in h, 3hx. That gives you quadratic in h, h square, and I have to take h going to h going to 0 limit. Okay, so what is it? 3x square remains 3x square as h goes to 0. Nothing happens to that. Because there is a h, it becomes 0. That becomes 0. 0 plus 3x square is 3x square. So that's your answer. Okay? So I'll write it down. I'll go to the previous page and I'll write here another one. If I take x cube, then the f prime of x, what happened? No.
Move it side.
Why this guy came here? F prime of x is equal to 3x square. Enjoying? Okay, I want one more. And that will be very useful. And it will not be any more difficult. Is that okay? 15? Okay. Let's go to page 4. How about this? Can you do that? Now you need to know f of x plus h to the 100. Okay, we would have so many terms and you need to know all the coefficients, right? So it's going to be very challenging. So you might use binomial theorem. I will show you how to do it without knowing anything more than what we have done already. No need for binomial theorem. You don't need it. Okay, so let's do this one. And since there's nothing special about 100 here, I will do it for arbitrary positive integer n. Okay, so I want to do it for x to the n, where n is a positive integer. You remember how the set of integers is denoted? Set of integers is denoted by z. Okay, but I'm restricting to positive ones only, so z plus, positive integers only. Okay, let's take this. What is f of x plus h? That is x plus h power n. Now this time I'm not going to write the entire explanation, because it is not needed. I don't want to use binomial. Okay, using binomial expansion really kills, it's unnecessary, it's overdoing it. Okay, so what is the slope at point x is this, x plus h to the n, which is fx plus h, minus x to the n y divided by h in the limit h going to 0. Okay? So let's take x plus h. X plus h to the n. That's what we want to take. This is what? N is integer, some positive number. So it is x plus h times x plus h times x plus h times x plus h times x plus h. How many factors? N factors. So there are n factors. Okay? Okay. Let's multiply. Okay, it's nice to multiply nicely. So I take this x. Okay, let's think this way. I want to generate h to the 0 term. Is it difficult? Is it getting difficult? No. See, in this expression, let's go back here. When you had x plus h cube, there was a term which had h to the 0. There was a term which had h to the 1, h to the 2, h to the 3. Okay? If you go to the square, f of x plus h, where f of x was x square, f of x plus h square, there is a term which is h to the 0. There is another term which is of which contains h to the 1 as a factor, another term which contains h square. So the highest power of h is same as what you have here, and the lowest power of h is 0. Okay, that's what you saw here in x cube. And you can, I'm sure you can argue for yourself that the same is true here, right? After all, you are just multiplying these terms. Okay, so let's look at h to the 0 term. H to the 0 is 1. How are you going to generate a term in this product which will have no h? That will happen only when you multiply this x with that 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 x. And there is only one way to get that term. Okay, so you get x to the n, x into x square into x cube, so on and so forth, x to the n. Now I want to look at the linear term in h. Linear term, which has a factor of h. When I am multiplying all this, if I take h here and multiply all other x's, so h times x times x times so on and so forth will give you h times x to the n minus 1. Good? But then instead of taking h from here, you can take h from there and take x here. X times h times x times x times x times x, that also gives you h n to the n minus 1. So that's the second term. But you could take h from here and x from this and that and all others. That again gives you this. How many such terms are there? The number of such terms are the number of ways in which you can choose one of these from which you want to take h. So if you choose this, it gives you one such term. If you take h from here, x is from everyone else, another term. If you take from this one h and x is from all others, again the same term. So there are how many such terms? There are n such terms because there are n such factors. Then there will be another term which will have h square x to the n minus 2, because you can take h from here and there, right? And then x is from everyone else. So that will give you h square times all the remaining x's, they are n x to the n minus 2. And there will be some number here. I can calculate this. I know how to do it. Okay? But I don't need to. So let's say some number here. I don't care about it. And you will know immediately, very soon, why I don't care about it. What about the next one? It will have h cube x to the n minus 3 and some other number here. Okay, so and so forth, and finally you have a term h to the n. That one is very easy, so I will tell you. How will you get that term? What is the coefficient? There is only one way. If you take h from each of these, so there is only one way to generate, so that coefficient is 1. Okay, good. So that's what we have. X to the n, n h x to the n minus 1, then h square piece, h cube piece, and h to the n piece. Now let's take f prime of x. Is it visible?
Yes. Yes.
Huh? Comfortably?
Mm-hmm.
F prime of x is x plus h to the n minus x to the n as h goes to 0, which is what?
Over h.
Huh?
Over divided by h.
Divided by h. Okay? So when I take this difference, x to the n will get cancelled with that x to the n. That will go away. Then you have nh x to the n minus 1. Shall I do it a little slowly? Maybe I'll do it slowly. So we have f of x plus h.
You can
Huh?
you can go back to the last sheet.
Huh.
Just move the.
But are you sure it will not? ठीक है, it's okay. Let's try.
Yes, that's it.
Let's try. Good, thanks. So if I have space, I will do it neatly then. So what is f prime of x? F prime of x is x to the n plus n h x to the n minus 1 plus some number here h square x to the n minus 2 plus this term, okay, plus all those terms plus h to the n up to here minus x to the n. Minus x to the n is because I am taking the slope divided by h. Now you might be worried, like I have not calculated these coefficients, how am I going to get the slope correctly if I don't know those numbers? Let's see what happens. Okay, x to the n will cancel as always, h to the 0 term will cancel always. Okay, why? Because in h going to 0 limit, f of x plus h is same as f of x. So no surprise that they cancel. So linear term, the term which has one factor of h, cancels against this factor and gives you n x to the n minus 1 plus something which I have not calculated here, but it has h square divided by h, so it has h into x to the n minus 2 plus second one. After this, there will be a term with h cube x to the n minus 3 divided by h, so it will give you h square x to the n minus 3. Remember, when I write this hash symbol, that does not mean that this number and that number are same. These could be different. Okay, I'm just writing whatever number here. So and so forth plus h to the n divided by h is h to the n minus 1. And now I take h going to 0 limit. Now you see, other than this term, every other term has a piece factor of h. Now when I take h going to 0, all those factors are just going to be 0. And that's why I don't need to know these numbers. Okay, so what do you get? You get nx to the n minus 1. Okay, that's your answer. So let's go to the next page. So what do we have so far? F of x, okay, and y. Okay, and this is f prime of x. So f of x, if this is a constant, we got this to be 0. If this is x, we got it to be 1. That's the 45-degree line, slope 1. If it is x square, you got 2x. Remember, I remember, you can check in your notebook. Okay, if you have x cube, you got 3x square, and if you have x to the n, where n is a positive integer, then you got n x to the n minus 1. Okay, that's thing. Now you will also see another way of writing slope. So instead of saying f prime of x, sometimes people will write, or actually often they will write this. Take this as a symbol, one symbol. What is that symbol? Given a function of f of x, a d over dx is what gives you the slope. That's a symbol. Okay, what's the meaning of all this? The meaning of all this is that this is f prime of x. But what is f prime of x? Okay, this is same as that, there is no difference. These are identical, it's just a different notation. And of course, because this is this, it means this is also this. This is called the first derivative, or just simply a derivative of the function of f. Okay, so this is called derivative of f at x. Okay, because the derivative will depend on the point. Okay, so we read d over dx, either dy dx or d over dx of f of x. Okay, but remember, what does that give you? The derivative gives you the slope. It is just the same thing. Okay, so what is d over dx of x? That's the slope of x. What's the slope of x? That's 1. We found it. What's d over dx of x square? D over d of x square is this. We have already done that. That came out to be 2x. What's d over dx of x to the n, where n is a positive integer? It is n x to the n minus 1. Right? So that's called a derivative, or a first differential, or a first order derivative. These are all names given for this thing, but they all mean the same thing, slope. Given a function, this will give you the slope of the function. Okay, so that's the concept of derivative. Let's now do one thing, a last thing in this one. So let's take f of x is equal to x square. What is the slope? Slope at any point x is 2x. Or same thing, what's the derivative of x square? That's 2x. Okay, these two are identical things, no difference. Now you may ask, what is the derivative of or what is the slope of this function at x is equal to 2. Okay, this symbol means find the slope at x is equal to 2. What is that? Slope is 2x. So evaluate 2x at x is equal to 2. What is 2x at x equal to 2? 2 times 2, that is 4. So the slope is 4 at x equal to 2, or identically in this language, d over dx of x square at x is equal to 2 is equal to 4. Is it okay? Okay, we'll stop here and we will go back to our condition on these value, on how the function is behaving near local maximum and the local minimum, using this language of derivatives or slopes. Okay, how to tell that. Stop here.